Am I audible?
Yes, audible.
Okay.
Uh,
So, hello, good afternoon.
uh,
Give a brief intro about you and yourself.
I'm from RK College, and
Debjit, your voice is cracking.
I think there is
hello.
issue with your internet.
हाँ मतलब ये गांव में हूँ ना, तो इसलिए थोड़ा ऐसा नेट का इशू है.
Okay, no problem. Okay, so give a brief introduction.
Devjit, I am Devjit Sett from RK College. I have completed my BSc honors in statistics from that college. I have done my schooling from 5 to 10 in secondary schooling from RKMV Purulia, and higher secondary schooling from Varandrapur School. And that's it. I guess.
Okay, thank you. And have you appeared for any other competitive examinations?
JAM, email
Okay.
2025.
Could you briefly tell us where you applied and how you think you performed?
Please repeat. Uh, I don't
Could you
understand.
briefly tell that how you think you performed?
In the written exam,
No, no, in JAM.
hmm, hmm, yeah, I can do better, I guess, but hmm, that is fast now. So I don't think about that much. Yeah.
Okay. And how much you scored in PSA according to yourself?
Yes, I scored 102, but
Okay.
my PhD exam is not well.
Okay.
मतलब
That's good.
बहुत ज़्यादा mistake करके आया हूँ.
Okay.
I have
No.
done so much silly mistakes
Okay.
that that's why worried about that.
And in interview, continue in English. Okay. That is just be confident. Okay. That is not a
Oh,
problem. Okay.
okay,
Are
okay.
you comfortable now? So we can start.
Yes, I am comfortable.
Yes.
Okay, okay. Yeah.
Okay.
So,
So, uh, choose a topic between real analysis and linear algebra.
Mm, Linear algebra.
Okay, so write a problem. So uh, consider a matrix
अच्छा,
or
अच्छा. ये वेट अ मिनट, मतलब ऐसे व्हाइट स्क्रीन पे लिखना है, या मैं कोई ऐसा किताब, मतलब ऐसे कोई कॉपी लेके आऊँ?
anything that if you write in exercise
ये
that is also okay. Just hold the camera and so that I can see your steps. Okay, that is not a problem.
ओ, ओ, अच्छा, मतलब ये यूट्यूब थोड़ा होस्ट बनाना पड़ेगा, क्योंकि वो व्हाइट स्क्रीन पे, मतलब व्हाइट स्क्रीन पे लिखना पड़ेगा मुझे, तो इसलिए थोड़ा जाके स्क्रीन शेयर कर पाऊँ.
Okay, okay.
हेलो, am I audible?
Yeah, yeah. Okay, so
Hello? Hmm.
consider a matrix M of order n cross n. Okay. Now, entries of I comma j entries of m is a random variable xij. Okay.
अच्छा.
Xij is Bernoulli half. And IIT for all I all j. Okay. Okay.
Okay.
So I want find expectation of date of M.
It's a determinant of M.
M. Yes. Not date of M is a random quantity.
Random
Very random
quantity.
quantity. Okay.
Hmm. M is a n-cross-n matrix, where Mij equals to Xij random variables and Xij IIT Bernoulli have for all Ij. So I have to
Yes. Yes.
find expectation determinant of M.
Yes. Basically, M is a random matrix.
Hmm. Okay.
Yes.
Hmm. एक प्रॉब्लम हो रहा है लाइक मैं आप लोगों का एक्सप्रेशन नहीं देख पा रहा हूँ ताकि समझ नहीं पा रहा हूँ कि सही हो रहा है या गलत
Oh,
हो रहा है
okay, okay, okay.
तो,
Sorry. Okay, but I didn't
हम्म,
understand one thing. You have start with date of m, and in this line you have written
हम्म,
x11 plus x12 plus x1 n into date of n minus 1 plus n minus 1. So you are uh,
हम्म,
uh, approaching with a recursion, right? Uh,
रिकर्सिव हाँ 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 यस
yes,
यस
but uh, I uh, uh, I have fixed n, right? I mean, n is not known, but n is fixed.
यस
So, how you are breaking it in a recursive pattern?
लाइक मतलब जो int like I normally have and so when मतलब when and consider the coefficient matrix, then also it is a matrix of Bernoulli half random variables. So that's why I thinking is same. It is showing same pattern or same characteristic as the M n cross n matrix. That's why I'm approaching like this.
Yes, you are right. That is not a problem. Even what you are telling, that is right. But the thing is, here the matrix is a random matrix. Okay, so this matrix has a random. Matrix has a distribution and many more things. So you are saying they will be
Mm,
almost not. They will be same characteristics. So when you are claiming this, you have to again prove this. Okay, or you have to give supporting statements. So okay, you proceed in this way, that is not a problem. But okay, now do this. What you are claiming is right, but you have to again, if you take this path, you have to give more supporting statements. Okay, but proceed now. Okay.
that's
Okay.
supporting statement. Supporting statement like um, I am
That a random
I
uh,
understand what kind
yes,
of uh,
yes, that is a
no,
part
I
of random
understand what
matrix
kind of
is.
supporting statement.
Yes, and
Yes, like uh,
establishing those statements is quite tough.
if,
Okay, that are sub part of
oh,
random matrix is again same as same nature with aim. That's part. Okay, now just okay, proceed. But it will hold, in this case it will hold. Okay, you can assume that as you do not have
uh,
random matrix. Okay, okay.
mm, I am done.
Okay, so you have find xn is equal to n factorial by 2 to the power n. Okay, so let's start with just take consider x2. Okay, just put n is equal to 2. Okay, what you have done in this problem, you have started with n and then just take a subpart of n minus 1 cos n minus 1. So now start with n is equal to 2 and do the same thing. Let's see um, that happens or not. Okay, x2 is
That's
m is of order 2 cross 2. You have 4 matrix, I think. x1 1, x1 2, x2 1, x2 2. Now you can then write determinant of. Okay, okay, okay. So I think you have uh, just come
Hmm.
again. You have write date of m is equal to date of m n minus 1 cross n minus 1 into x11 plus x12 plus dot 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 x1n. Is x11 x12 x1n all will be summed or something plus minus here?
Ah.
Okay.
I have to be careful.
Yes.
Hmm. Hmm. Minus plus minus plus ऐसा.
Obviously. And after that taking expectation will be again some problematic. Okay, let's see.
Hmm.
You can write it in below.
Oh, okay. Like if n is odd, then there will be a half factor, or if n is even, then it becomes zero.
Okay. Then you cannot divide this xn by xn
Hmm.
minus 1, right?
Uh, hmm. 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 Can you provide some hint?
Yes, obviously. So, to be honest, you have specified that you want a question from linear algebra. That's why I gave it. It is a not a problem of probability. First is that. So when I am providing you Bernoulli half, so uh, then every random matrix is uh, equally probable, right?
Hmm.
As
Yes,
all are IID. And now expectation of data of m, then that will be a simple average of all possible data of m, right?
determinant. All
M.
possible data.
Uh,
Yes, yes.
and now can you say now different numbers of how many m is possible? How many different random matrix is possible?
ये यही तो नारायण बोल रहा है. Now we'll see. ये one, two, three, two to the power, two to the power. So total number of elements in the determinant.
No,
So
no. I am saying that
n
so
into 2 to the power n square.
2 to the power n.
2 to the power n square.
No, I
N
am
square. 2 to the
no,
power
no.
n square.
I am
Hmm.
asking you how many
Oh,
different matrix is possible.
how
Okay, 2
many
to the power n
different
square. Okay, that's right.
matrices?
That's right. That's right.
Mm-hmm.
So
Hmm.
uh, now expectation of data of m will be 1 by 2 to the power n square into sum of all possible such determinants.
Such determinant. Yes.
Okay, so try to find sum of all such determinants, or sum of all such possible determinants. It depends on only that thing, right? If you find that, then that will be divided by 2 to the power n square.
Mm. Yes.
And another hint is in the previous your in previous procedure you get that if n is even, then the expectation will be zero,
Mm.
right? So another thing is
Mm. Mm. Mm.
if n is even, sum of all possible determinant will be zero, right?
Mm. Mm.
So try to prove or establish that thing. You get my point, right?
Mm. Yes. Yes.
Okay. Okay.
I mean here it was not like it will be in two cases. N is odd or n is even.
No, that will not
I
need.
mean sum of all possible determinant
Okay,
that
so
will not
share
need.
your thought. Share your thought. No.
No, I think there will be two cases. So, I mean, okay, I am trying.
Okay, not a problem. Just share.
Hmm, I am trying.
Okay, okay.
So,
Uh, so note sum of matrix. This all possible matrix will give determinant zero, right?
I don't understand.
Okay, so you have 2 to the power n square possible matrix.
Yes.
Some of them will have zero determinant. Some of those matrix, not SUM is
Some
sum
of
of those
those
matrix will be give zero determinant, right? Consider the matrix with all zero.
uh,
Okay.
That will give that will give determinant zero,
Yes,
and sum
exactly.
of all non-matrices that will also. Hmm. So
So we have
again,
to
if two rows are same, then hmm,
think about those matrices
okay.
who have non-zero determinant.
Hmm. Not the determinant. Uh,
Okay, I am giving you another hint. So in this side, write identity matrix. In this white side,
hmm,
this side,
oh, okay.
identity matrix of order 3.
Hmm.
It has determinant 1, right?
One, yes, yes.
Can you think that a matrix um, connected with this and has determinant -1?
Hmm.
Very good. You have just changed a row, and you get uh, one is determinant 1 and another is -1. So, and
Yeah,
note,
that's
if
right.
we proceed with n is equal to c, these two will be belong. These two will possible matrix, right? And they will 1 and -1. Okay.
Hmm.
So use this fact. It will.
Oh, oh, so hmm, like n factorial into n minus 1 factorial as a this such possible cases will arise. Love.
No. Okay. Let's continue.
I mean the number of times that I can change the rows,
Yes, you can change n-1
like
rows. Right.
n minus 1 rows, and
But sum of all those will not be 0, right?
mm,
Okay. Thank you. Okay, I'm done. Suvanjan? Suvanjan?
Yes, yes.
Okay, I'm done. Thank you, Devjit.
yeah.
So, Debjit, can you please clear the board? Okay, okay. This much will work. Okay. So, okay. So my question is, suppose we are having the data of 25 students on marks of their probability and inference courses. Okay.
Mm.
Okay. Now, one claims that as the marks of probability increases, then marks of their inference also increases. And if marks of probability decreases, then marks of inference also decreases. Mentioning all the
Mm.
assumptions, formulate a test of hypothesis to conclude the above problem.
Mm.
So here n is 25, right?
Mm.
Okay. So do you know how to derive the test statistic T?
It comes from sampling distribution. When rho equals to 0, then x bar, y bar, mu x, mu y, and rho are independently distributed, and from there, like if mm, uh, if our sample population coefficient is
Yeah, yeah,
some
yeah. I am not telling you
constant
to derive it. I am just asking about the
1.
intuitive idea. That's
Oh,
correct. That's correct. And
hmm.
my question is, in this process of deriving the
X
distribution.
sorry. I mean, when rho equals to 0, then x bar, y bar. I mean, the sample mean of x, sample mean of y, sigma x, sigma y, and sample variance of x, sample variance of y, and sample correlation coefficient r. They are independently distributed, and from there we can find this find this statistic T.
Okay, I didn't hear you properly for the
Sorry.
last time. Okay, okay, that's okay. Now, I want to ask, in the process of deriving the distribution of the t, the first thing we do is, without loss of generality, we assume mu x and mu y as 0 and sigma x and sigma y as 1. So we write without loss of generality. So why generality is not loosed when assuming the means as 0 and variances as 1? Can you intuitively justify it?
I mean, when I derived it, when I learned it,
Your
then
voice is cracking,
I
Debjit. I
didn't
really can't
learn
hear
that.
you properly.
Sorry. I mean, hello. Am I audible?
Yeah, yeah, yeah. Now you are audible.
Hello. So I was actually telling that we didn't assume that way. Like we we done it in a generalized version. I mean, as norm bivariate normal mu x mu y sigma x sigma y. It's just assuming rho equals to 0.
So can we do that? So that's another approach. You can assume mu x, mu y, sigma x, sigma y as it is, but without loss of generality, we can assume, right?
Oh,
That
okay.
means are 0 and variances are 1. Can you tell me intuitively? I am not asking for a rigorous mathematics proof, just intuition that
Oh,
why can we do that?
okay. Why can we do that? Okay. Why can we do that? Assuming these as means as 0 and variance as 1 as a special case, right?
Yes, yes.
Okay. Um, okay, yeah. Actually, when we assume that mu x and mu y belongs to real number and sigma x sigma y is greater than 0. So for and for 0 this belongs to real number set, and 1 that belongs to also greater than 0 in real number. So for a specified case that can be happen. Um,
No, that's not exactly the answer. Uh, Mainly, see, correlation coefficient usually doesn't change by a me origin or a scale shift, right?
oh, scales.
Okay, so
Yes, yes.
that's why without loss of generality, we can assume that. Okay,
Mhm,
okay.
mhm, mhm.
So, got it?
Okay. Yes, yes, yes.
Okay, okay. So, this
Continue.
is a parametric test in literature that you have written on the board. Now, can you suggest me any non-parametric test for the above problem?
Non-parametric test. Actual non-parametric test. Suppose here delta 1 is a location parameter for the x and delta 2 is the location parameter for the y. Okay, so we have a data set for the both, and we see delta 1 as a delta 1 dash and delta 2 as delta 2 dash. Now we are taking another data set and seeing delta 1 as delta 2 dash, where delta 2 dash delta 1 as delta 1 double dash, where delta 1 double dash is greater than delta 1 dash, and we are trying to test whether delta 2 double dash is greater. greater than equal
I
to
don't
delta
get
2
you.
dash.
I am actually not getting you. So, can you please write in the board that what are you trying to say? So you are telling that x1 to xn, they are IID some capital F of x minus delta 1, and y1 to yn, say ym, they are f of x minus delta 2, and you are specifying the value delta 1 equal to delta 1 dash and delta 2 equal to delta 2 dash.
Hmm.
So is that your hypothesis, or you are just specifying the location parameter?
Specifying, I am actually specifying the location parameter.
Okay, you are specifying yourself. Okay, okay. Then what is the necessary of testing? I mean, if the location parameter is the only parameter, so in the testing problem we usually test for a parameter, right?
Yes, and for another data set we will do the test, like, and for another.
Suppose you have only one data set that I have given to you. You don't have any another sort of data set. Only you have the
Oh,
observations of marks of
okay.
probability and inference courses for those 25 students.
Hmm.
May I give you a hint?
So basically, we have can we, can we do can we do Spearman rank correlation coefficient? Yeah, can we
Yes,
consider it?
of course, of course.
Actually, we have to check for the monotonicity whether both are increasing or decreasing. So I guess that may help.
You have actually correctly guessed the test statistic. We usually in non-parametric this type of tests are done by two ways. One is Spearman rank correlation, another is Kendall's tau. So Kendall's tau is now out of your scope, but okay, Spearman rank correlation is good. But can you write the Spearman rank correlation test statistic and justify the critical region for the same?
Sorry.
So UI is the rank of xi in the sample, I mean, among the x observation or the total sample?
Rank of, like, the sample. I am ranking the sample observation.
Yeah, I am asking, you have the data x1 to x25 and y1 to y25. I am asking that UI, you are mentioning the
Mm-hmm.
rank of the xi's. Rank of xi you are mentioning. So is that rank among x1 to x25 or x1 to x25 plus y1 to y25?
X1 to X25
Yes.
and VI Y1 to Y25 and Can we do
Here
it?
you are rejecting for large values, right?
Yes.
Okay. Now, coming to your test statistic, is it correct?
Uh, I can't actually
In the denominator, it will be n square minus.
summation I in the denominator.
No, no, no.
N square into
N into n square minus 1.
uh, yes, yes, yes. Uh, one.
Okay. Now, can you justify that why there is a loss of 2 degrees of freedom? We are writing t of n minus 2. Can you justify that why there is a loss of 2 degrees of freedom?
Mm, Uh, Actually, mm,
Hello?
I I can't. I don't know.
Okay, okay. Give it a thought. Okay, later. Now, my next question is what do you mean by unbiased test?
Unbiased test. Mm, Am I have to write it or just
No,
tell?
you can just tell it. You can just tell it.
Suppose we have a testing problem, age such that x follow p naught and against alternative hypothesis age naught or age one suppose x follow p1 belongs to such p minus p naught, then unbiased, then our test is said to be unbiased if expectation, I mean size, the power is always greater than the size, so expectation are
Yeah,
test
you
phi
don't need
x
to write
is
the expression. That's the simple definition. For a testing procedure, if power is greater
mm,
than the size, then it is known as the
size,
unbiased test.
then it is known as unbiased test.
Yeah,
Okay,
perfectly all right.
yes,
So, is MP test and UMP test always unbiased?
yes, they are always unbiased.
Can you say it in the same way for likelihood ratio test?
If MP test or UMP test exist, then LRT test are always MP test and UMP test. So for that, this is unbiased, but in general, LRT tests are not always unbiased.
Yeah, but
Like in general, LRT test is not always unbiased.
yes. Now, for this particular problem, do you know that how these things came up? That those entire test statistics that you have found, that's actually a result from likelihood ratio test statistics. Okay, so if you test for rho equal to 0 versus
Mm,
h1 rho equal to some rho naught, which is non-zero, then you will end up with something, this
Yes.
t. Okay. So, but we know actually the distribution of
Mm.
the t only under h naught, that is rho equal to 0. So from this structure, can you itself comment
Yes,
that
yes.
the test is unbiased or not? As for checking the biasness, you have to consider the H12, that is rho positive. But do we really don't know anything about the structure when rho is positive? So can you say something about the unbiasedness of the test?
Sure. Uh, On the structure of the test statistic, I have to say.
You have to use
Hello?
the distribution, right? So for power, you
Yes,
have,
yes.
I mean, you have to use the critical region also, but for the power, you need H1. I mean, the
Yes, yes.
sort of distributions
The
of T under
distribution
H1.
for
Okay, but we
under
don't know
H1,
really,
but we don't
really,
have.
yeah, but we don't know really something related to that. When rho is positive, what is the distribution of the T? It's only possible under H no,
Yes,
when
yes.
rho is positive, rho is 0. So can we tell
Mm.
from here that yes, this test will be biased or unbiased, anything like that?
Okay. Mhm. So what under is not that is under is not. Yes, yes. Um, Actually, I don't know how to conclude. Um,
Okay, okay, no issue. Okay, give it a thought later. Okay, now Jeet.
okay.
Yes. Hello, am I audible?
Yes, yes,
Hello.
you are audible.
Okay,
Yes,
so
hello, audible. You
uh,
are audible.
okay, so uh, let x1, x2, xn follows Bernoulli P. So
IID,
find the UMVE of p to the power r. Yes, they are IID.
UMG,
P to the power r.
okay.
Okay, so why you have considered this T? Hello.
At easy as hello yes, as
Hmm.
it is the CSS, I mean complete sufficient statistic for T. Summation xi is
Okay.
complete sufficient statistic for P.
Okay.
Yes.
So is it unique, or there can be any other
No,
UMV?
sub I uh oh UMVB. No, I think it
Yes,
is
like
unique.
the statistic that you have derived, is there any other statistic which will give us the same variance and it will be unbiased also?
Oh, you are asking for UMVB is unique or not? I think.
Yes, 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 yes.
Oh, T equals to summation xi is unique or not? I mean, complete
No,
in
no,
case
no,
of
no. I am not
competent
asking.
sufficiency.
No, no. I am
Huh?
asking that the
Oh,
statistic that you have written here,
then
t into t minus one dot 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 t minus r plus one, and you have balanced it.
it.
Okay, so basically, yes, yes. This thing, is
Hmm,
this thing like
hmm.
is this the unique UMVV for p to the power r, or there can exist any other form of statistics which will give you the same variance and it will be unbiased also?
No, no,
Why is it so?
no. I think it is unique. I mean,
Why do you
so
think so?
power se- we like if we comparing the coefficient of the after the expansion, then we can say it is, I mean, if we do it in such a way.
Okay. So you are considering any other estimate, or you are considering the same estimator?
No, I am trying to show that it is unique.
Okay, 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 okay. Proceed.
And oh no, 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 no.
No, don't have to just give the intuitive, like give me the intuition. You don't have to give the rigorous proof. Just give me the intuition. Like it is complete sufficient
Oh,
statistics. Like which is the particular condition that gives us that MVV is unique? Which is a key point?
hello, like your voice is cracking. I don't understand.
Hello, hello. Am I
Hello,
audible now? Hello.
please. You, yes, yes, you are audible now.
Okay. So
Yes, hello.
okay. So what are the key points to, like, what you are considering a complete sufficient statistics? So basically
Hmm.
uniqueness depend on a particular type of property of a statistics. Okay, so can you guess that, like, or can you tell me that, like, on which it depends,
Uh,
on which
like
exact property it
from
depends?
Lemon-Seffy theorem.
Yes, from Lemon-Schaffer theorem.
Lemon-Seffy theorem that in, from Lemon-Seffy theorem it is a I mean it is a function of complete sufficient statistic, so that's why it is unique and UMV. I mean
Yes.
that T is unique. That's why we get
Hmm.
this is at as unique
Yes.
UMV.
Yes. Asking you what is the, like, what is the main property here? is only completeness needed here or
Completeness.
sufficiency needed here? Okay, so completeness tells us
I
that the
mean
UMVB will be unique.
that uniqueness that is unique. Yes, yes. Completeness. Matlab
So
from
you are
completeness
trying
we
to say
can
that
conclude
completeness.
that.
Yes, yes, okay.
Yes, yes.
So
For
suppose
the
I have an
uniqueness,
unbiased estimator.
complete.
Okay, yes, yes. Okay, it's perfectly fine.
Yes.
I
So
got
one
it.
thing I want to ask,
Now, okay.
Does Lemon-Sheffy theorem anywhere states about the uniqueness? It only says, right, that
Uh,
if it is complete sufficient statistics and if you are able to form any unbiased estimator based on that, that's the UMVV. So does Lemon-Sheffy theorem tells anything about the uniqueness of a UMVV?
no, I mean in the proof we do like suppose we have two I mean we have two functions, two estimators T1 and T2, which are function of that complete sufficient statistic. Then we don't have T1 and T2 because of that completeness. Then T1, Tn and T2 becomes the same because of the completeness.
Yes. Yes. Okay.
Okay, so suppose I get an unbiased estimator, okay, and it is a function of sufficient
Hmm.
statistics. So will it be UMVV?
Okay, no, no. That is
Uh,
just an improvement over the statistic, but we don't get the UMV from that.
Suppose it depends only on the sufficient statistics. It is a function of sufficient statistics only. It depends only on the sufficient statistic. So you have said that na that using Lehman-Sheffey you can if you find an unbiased estimator, the
Hmm.
you can the
Then
way you
that
have
is
showed
that.
me that you are basically finding an unbiased estimator based on the sufficient statistics, right?
Hmm.
Right. The way you have showed me that at first you considered statistics, suppose T, and you showed me that
Hmm.
it is unbiased, and then you told me that it is the UMVV. So is it always true?
Yes, yes.
So listen
Oh,
to me very carefully. I am talking about a sufficient statistics.
okay. Okay.
So is it always true?
No, for sufficient statistic, I don't think that that will be the UMV, that the
So can you
estimate
give
will be
an
the
example?
UMV.
Can you give an example?
Okay. Like only sufficient but not complete, and then it will be
Yes,
not the UMV.
yes, yes, yes. So
Uh,
give me an example.
hmm. I mean, I have to give an example for that it's not being UMV.
Yes, consider a function, consider a statistics that is a function of only sufficient statistics,
Function
and it is
sufficient
unbiased
statistic,
also.
and that
Okay.
is not. Hmm.
Yes, it is unbiased also.
And
Like
that is
provide me
not
two
the
unbiased estimators based on sufficient statistics that will give me the like that will give me the same variance. Okay. Or that will give me the same minimum variance.
oh. Hmm. Uh,
So forget about UMVV.
I
Just provide me an example of two unbiased statistics that will give me the same variance. Okay. Forget about minimum.
one meter having same variance.
Yes, yes. Just give me an example.
Hmm. Uh,
Do you need a hint?
actually, yes, I know.
Okay, think about the most prominent sufficient statistics. I am not talking about minimal sufficient statistics. Okay, so think about only sufficient statistics. When you think of a sufficient statistic, what is the first thing that come into your mind?
Yes, sir. Hmm. Normal theta square. Um,
Okay, forget about completeness. Like forget about completeness. Like will it hold or will it not hold? That will not matter. Just don't
oh,
think about the family of distribution. Just think that um,
sufficient statistic.
you only need sufficient statistics. Yes, yes. You only need sufficient statistics.
So the sample mean
Is it always true? Is it true for Cauchy distribution?
no, I samples for that. Uh,
Don't think about minimal
oh,
sufficient.
the sample,
Don't
the
think about minimal.
sample, the sample,
The whole
the
sample. Yes,
sample.
yes. Now can you
Okay,
construct?
the whole sample
Now
itself.
can you construct?
Oh,
Yes. So every statistic is a function of sufficient statistics. Okay, because the whole sample is a sufficient statistics.
yes.
Now consider any two unbiased estimator for
Now,
your parameter.
hmm,
Okay. Now can you give an example?
hmm,
Okay, give it.
I mean, no, only two unbiased estimator,
Yes, my
which have,
question was if yes, my question was if there is an unbiased estimator and it is only
hmm,
based on sufficient statistics, will it be the UMPV? My question was that. I'm not asking you to find the UMPV. My question was that. Just give a counter example. Okay.
acha, acha.
Do you understand what I was asking?
So
Okay.
basically, an estimator of the yes of the sufficient statistic, which is not UMP.
Yes. That's what I was asking. Okay, okay. So one more question from my side, that is, you have
Hmm.
considered that xi and summation xi square, like summation xi and summation xi square, both are jointly sufficient, but you
Hmm.
have considered only the
Hmm.
components of them. Like, is it valid here, or you have to consider both of them to build a function?
Hmm. I consider both of them here at the end.
Okay, okay. So your proof is not
Like,
complete. Okay, 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 okay. Go on, carry on.
so like that is, it is unbiased for theta square, but not even maybe.
Yes, yes, that is true. One more thing that I need to say, that the first thing is also a function of sufficient statistics, because basically your domain is basically R2 here. Okay, so your
Hmm.
sufficient statistics is in
Hmm.
R2, and you have taken a function in R1. Okay, you have
Like,
just defined a function
hmm,
in
hmm,
R1,
hmm,
that T1 square,
hmm.
you are not considering the effect of T, like T2. Okay, so
Hmm.
that function is itself a counterexample, because it is based on the sufficient statistics. You
Oh,
are not
okay.
considering just the thing. Okay, it is a function of sufficient statistics. You can give a
Hmm.
simpler example also. Like, suppose the sufficient statistics is the whole sample. Okay, suppose you have observations from
Hmm.
normal theta comma 1. Okay, so if you consider only
Hmm.
x1,
Hmm.
it is unbiased for theta. If you consider x2, it is also unbiased for theta,
Ah.
and it is also a function of
Like
sufficient
that.
statistics.
That is also understood.
Okay,
Hmm.
so in that way, like, you
Okay.
can like, you can construct a simpler examples for that. Okay, so
Yes.
my final
Okay,
questions to you
I
is,
understand.
okay, so my final question to you is that, find the UMV of indicator p greater than half,
Hmm.
and xi follows Bernoulli, like x1, x2, xn are IID Bernoulli p. The previous example that I have given.
Like
Yes, x1, x2, xn are Bernoulli p,
UMVV,
and you have to find UMV of indicator p greater than half. Indicator
indicator P greater
p
than half.
greater than half. Yes.
Sample is the previous one.
The sample is the previous one. X1, x2, xn is from Bernoulli p. Okay. Can you find an UMV for this?
Hmm. P greater than half. I mean, parameter is greater than half.
Yes, this is a parametric function.
Yes, yes. One. Uh, can I get some hint?
Yes. So, uh, say your thought process. Like, what are you thinking? What are you thinking now?
Like, we have to. I have to find that P greater than half. I guess indicator p greater than half.
Yes.
You mean 1 if p
Hmm.
greater than half and 0 if p less than half.
0 is p less than half. Okay. So for finding UMVV, at first, what you have to find? What is the first thing
CSS
that you will find?
statistics.
Yes. So you have the CSS statistics.
First is
Yes.
and yeah, and
Okay.
unbiased estimator for the parametric function.
Yes. So can you find an unbiased estimator for that based on the complete sufficient statistics? At first, try to find out that.
Mm,
Like the way you have found out for p to the power r, can you find something like that?
oh, I p to the power half, I p greater than half.
Yes. Yes. So can you construct something like this? What do your intuition tell you?
I for I know that for
Hmm.
for binomial distribution we can only estimate a polynomial of p. I
Yes.
don't know how to estimate this parametric function. I think we can only estimate a polynomial of p. I
Yes.
mean, a polynomial of p of
Yes.
order something. I don't think we can estimate this in a binomial in case of binomial distribution.
Yes. You can estimate this, but you cannot estimate it unbiasedly. Okay. You can
Oh,
estimate
oh,
this. You can have
sorry.
some bias estimators. Yes, you can estimate that,
Oh,
but you cannot estimate it unbiasedly.
but we can
So there is no
unbiasedly.
unbiased
Okay.
estimator, so no concept of UMV. Yes. So can you elaborate like
Oh,
why
okay, okay.
it will have only polynomial? Why can we estimate only polynomial
Uh,
things? So tell me
mm,
why?
that only we we can prove that like we can prove that using like expectation something
Hmm.
like
Yeah,
sorry
write
expectation
it.
tx equals to zp uh, in some x 0 equals to six to the power e to the power n minus 6. Now x equals to 0 to n dx is dx p to the power x 1 minus p to the power n minus 6
Yes.
so 0 to negative t to the power x n cx p to the power x summation n minus x p y equals 0 to n minus 6 minus 1 to the power minus sorry sorry minus p to the power a minus x minus y. So x equals to 0 to n, y equals to 0 to n minus x, tcx, ncx, p to the power n minus x is y, p to the power minus 1 to the power n minus x minus y, p to the power n minus y. So this is basically a polynomial for
Hmm.
p, I guess.
Yes.
That's why like
Yes.
GP becomes
Hmm.
GP becomes a polynomial of P, which we can
Okay.
estimate unbiasedly.
Hmm. Okay. Okay. Perfect. Perfect. So I am done. So Shubhanjan, do you have any other questions? You can ask.
Yes. Okay. So I am suppose for any parameter function, if I give you an unbiased estimator, can you tell me that whether it is UMVV or not? If yes, then how?
Like if it is a function of complete sufficient statistic, then we can say it is UMVV.
I am giving you just
Otherwise,
an
I don't.
unbiased estimator, and suppose that is not known.
Oh, unbiased estimator T is given, and also what what we have.
Suppose x1 to xn are IIT sum f theta x, and we are just say want to estimate parameters I theta, and we are giving an unbiased estimator, say tn x curve. Okay. Now, can you tell me that whether this is an
Hmm.
UMVV or not? Because see, unbiased estimator, if you can find two unbiased estimator for that parameter function, then you
Hmm.
can construct infinitely
Hmm.
many,
Hmm.
right? By taking their convex combination.
Infinite limit. Yes, yes,
So it's not
yes, yes.
possible to calculate all the variances of those unbiased estimator and to compare this one so as to obtain the UMVV.
Hmm.
We
Hmm.
can't do that. But is there
Yes,
any
yes,
necessary and
yes.
sufficient condition that will tell us that yes, this is the UMVV and yes, that is not?
Hmm. Like if we can show that T is unique, like
Suppose T is an arbitrary unbiased estimator, okay? You don't have, I mean, how can you say that unbiased estimator is unique? Unbiased estimator is not unique. I have
in
given you any unbiased estimator. I am typically asking you, is there any sufficient and necessary condition for an unbiased estimator to be an UMVV of that parameter function?
I don't know.
Okay, so if an unbiased estimator is uncorrelated with any unbiased estimator of zero,
Oh, ha.
okay, that's a
Hmm.
necessary
Hmm.
and
Hmm.
sufficient condition for an unbiased estimator
Sufficient
to be
condition to follow as well. Yes, 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 yes.
okay. So I am
Yes.
typically asking that.
Hmm.
Okay, okay.
Hello, Debjit.
Yes,
Am I audible?
yes, yes, you are
Okay, I
audible.
have a last question. Does MLE always exist?
MLE,
Yes, maximum likelihood estimator.
no? In, mm, no, like it doesn't exist.
It
Always.
does not exist in some cases, right?
Yes,
Okay, now can you give such an
it doesn't
example?
exist in something. Mm, like, suppose we have some sample from x1, x2 dot xn, um, from xn from uniform 0 theta, then in case of in this case theta, the MLE of theta, we don't have the MLE of theta. Like that's why we consider our supremum for the MLE.
I don't get it. Can you write? Why does not exist? And at first specify parameter space, right? You have to specify parameter space.
Right.
So theta is strictly greater than 0. Okay. Then why here does not exist? Emily does not exist in this case. What is the likelihood function? Can you write this? Yes. Now why Emily does not exist?
That's why, in case maximum does not exist, but that's why we consider the supremum, that argument of theta for which L theta have the supremum. That's why x
I
order
still
n, we consider
didn't understand.
x order n is the n. Oh, I,
So here Emily is X order n, right?
hmm
So he is typically asking you where it doesn't exist. In this case, Emily is existing.
uh, I don't have the example.
Okay, no worries. Thank you.
Do you have any question? Debjit?
Uh, what's I mean, what to do? How to be prepared for the
Your
time?
voice is actually breaking. We can't hear you properly.
Hello, am I audible?
Yes.
Your voice is breaking.
Is hello, hello, am I audible? Hello?
It is still not very clear. It's
Write
breaking.
it in the chat box. We can see there.
Hello,
Yes, now you're audible.
Yes.
hello. Actually, I am telling like, I mean, about some feedback. How can I improve my performance?
Just
Actually, I
from
was
my side, 2 points: be confident and talk in English, and just you have a pretty good uh, foundation. So just go with
Yes.
the counter examples. This type where MLE doesn't exist, where EMP doesn't exist, and more counter examples from real analysis part.
okay.
And
And
how
just
many questions you
Okay,
have
okay.
attempted in PSB? How many questions you have attempted?
I mean, I actually attempted 7 questions, but 2.5 are wrong. Actually, I mean,
Is it
four and
completely
half.
wrong
I
or
am sure
partially
that
wrong?
this.
Like, is it
I
completely
mean,
wrong or
one
partially?
question is complete. One question is completely wrong, and like এখন কি বাংলায় কথা বলতে পারি মানে, তাহলে একটু
না,
বলতে
হিন্দিতে বল,
তাড়াতাড়ি
হিন্দিতে
সুবিধা
বল,
হতো মানে ওই যে।
হিন্দিতে বল, অসুবিধা
আচ্ছা,
নেই।
অ্যাকচুয়ালি
না না না, তাহলে
ওকে
স্যারকে
ওকে
ওইভাবে বলে দে,
অ্যাকচুয়ালি
জাস্ট এটা জাস্ট এমনি এর জন্য না, যাই হোক।
ওকে ওকে, হ্যাঁ ঠিক আছে, বাংলাতেই বল, বাংলাতেই বল,
বল
অসুবিধা নেই।
বল।
অ্যাকচুয়ালি ওই যে যেটা মিডিয়ানের, যেটা মিডিয়ান দিয়ে হতো ওই মিনিমাইজেশনটা, ওটা অ্যাকচুয়ালি আমি ফার্স্টেই ওটা আমি অ্যাজিউম করে নিয়েছি যে এরর সামটা 0 হবে। তো ওই জিনিসটা পুরোপুরি ভুল হয়ে গেছে, দিয়ে আমি ওইখানটা ওয়াই বার এক্স বার দিয়ে মানে যেটা বি, এটা যেটা সেটা ওয়াই বার ইকুয়ালস টু এ প্লাস বি এক্স বার করে আমি এটাকে সরিয়ে দিয়ে ওটাতে ওয়াই বার ইকুয়ালস মাইনাস বি এক্স বার করেছি। তো ওটা পুরোপুরি ভুল চলে গেছে। বাকি যেটা এমএলইর যেটা ছিল 10-এরটা, সেটাতে এরকম লাইভলিহুড ফাংশন অব্দি ঠিক রেখেছি, কিন্তু ওই মাথায় আসে যে ওটা ল্যাগ্রাঞ্জ মাল্টিপ্লায়ার লাগাতে হতো। তো ওই মানে
আচ্ছা আচ্ছা
বাকি ওই দুটো গেছে, মানে বাকি 4.5খানা এরকম ঠিক আছে। আর আর একটা আমি মানে এত বাজে বাজে ভুল করেছি, এ ভি ইকুয়ালস টু যে ওই জিনিসটা ছিল যেটা এ ভি ইকুয়ালস টু এরকম ভি ডি হতো, তো ওইটা যে, কিন্তু আমি ওটাকে ডি ভি লিখে এসেছি, মানে এরকম খুব বাজে বাজে ভুল করে চলে এসেছি।
আচ্ছা, সিলি
সেইখানে
মিস্টেকও
আমি
হয়েছে, ঠিক আছে।
প্রচন্ড মানে আমি এরকম, হ্যাঁ মানে এরকম এত বাজে বাজে আমি করে এসেছি, আমি নিজেই কনফিডেন্ট নই যে আমি পিএইচডি তে কি করে এসেছি। মানে আমি খুবই মানে
আচ্ছা
জানি না
ঠিক
কি
আছে,
করে এসেছি।
অসুবিধা নেই, মানে
আরে
ওটা ওটা
আরে,
অতটা ম্যাটার করবে না, জাস্ট খালি
তোর
জাস্ট কনফিডেন্ট থাক। আর তোকে যদি জিজ্ঞেস করে যে ওই পিএসবি থেকে কোশ্চেন, তাহলে বলে দিবি যে আমি এই জিনিসগুলো ভুল করেছি, আমি তখন এইভাবে ভাবছিলাম। তোর থট
হ্যাঁ
প্রসেসটা বলবি, ঠিক আছে?
হুম।
আর
বুঝতে
হাই চান্স
পারলি?
যে তোকে তোর পিএইচপি থেকে কোশ্চেন করবো, কারণ যেহেতু পিএইচপি তে সিলি মিস্টেক আছে, ঠিক আছে।
হ্যাঁ, আর
হ্যাঁ,
পিএসবি রেলিভেন্ট
আচ্ছা
টপিক
আচ্ছা।
গুলো দেখে যাস, মানে
এক্স্যাক্টলি
লাস্টে যেটা
এক্স্যাক্টলি।
বললি লিনিয়ার মডেলসে, ওই টপিক গুলোতেও এমনি গস মার্কভ থিওরেম, তারপরে গস মার্কভ সেটআপ, বেস লিনিয়ার আনবায়াসড
আচ্ছা,
এস্টিমেটর, ওইটার সাথে যেটা দেখবি, মানে যেটা প্রবলেম দিয়েছিল সেটা তো নর্মাল গস মার্কভ সেটআপ না, সেখানে তোর একটা কনস্ট্যান্ট প্রবলেম দিয়েছিল। ঠিক
কনস্ট্যান্ট
আছে,
দিয়েছিল, হ্যাঁ।
কনস্ট্যান্ট প্রবলেম দিয়েছিল, তো ওইটার ভ্যারিয়েন্স এর সাথে তোর মানে গস মার্কভের মানে যেটা লিস্ট স্কোয়ার এস্টিমেটরের ভ্যারিয়েন্স থাকে সেটা দেখবি সেম আসবে। তো এই ডিসক্রিপেন্সি গুলো কেন? কারণ যেহেতু গস মার্কভেরটা বেস লিনিয়ার আনবায়াসড এস্টিমেটর, এই টাইপের কাউন্টার গুলো একটু পড়ে যাস।
হুম।
হ্যাঁ হ্যাঁ,
আর
বাকি তো
চাপ নিস
ঠিকই
না।
আছে মোটামুটি। হ্যাঁ,
দাদা
বেশি চাপ নিবি না। আর
তোমার
যদি
পেয়েই
মানে
যাবি।
এখানে যেমন
Yes.
ইন্টারভিউতে বললি লিনিয়ার অ্যালজেব্রা, ওখানেও লিনিয়ার অ্যালজেব্রাই বলিস, ঠিক আছে? অ্যানালিসিসে বেশি ঢুকিস না ইচ্ছা করে, যদি কোশ্চেন
হ্যাঁ
করে
হ্যাঁ
তাহলে
হ্যাঁ।
বলবি, ঠিক
আর
আছে?
হ্যাঁ, আরেকটা কথা,
কারণ
যদি
হ্যাঁ,
মানে ফার্স্টে লিনিয়ার অ্যালজেব্রা মানে ফার্স্টে যদি তোকে ম্যাথসের চয়েস জিজ্ঞাসা করে, তারপরে যদি তোকে বলে যে তুমি ইনফারেন্স দিয়ে স্টার্ট করতে চাও না মানে ম্যাথামেটিক্স, ম্যাথামেটিক্স নিয়ে নিবি। কারণ আমার ক্ষেত্রে যেটা হয়েছিল, লাস্টে গিয়ে আমি বলেছিলাম লিনিয়ার, বাট আমাকে ধরেছিল রিয়াল। তো যিনি ও ভুলে গেছিল আমি
ও
কি চয়েস দিয়েছিলাম। তো ওই ক্ষেত্রে যদি কনফিডেন্ট না থাকিস,
আচ্ছা
আগের থেকে করে দিতে পারিস, কোনো অসুবিধা নেই, আগের থেকে ম্যাথসটা দিয়ে নিবি, সেফ থাকবি।
আচ্ছা আচ্ছা আচ্ছা, ঠিক আছে।
হ্যাঁ। আর
থ্যাংক
মাঝে
ইউ
মধ্যে
থ্যাংক
আর
ইউ
কি কি
থ্যাংক ইউ।
হয় বলতো, পিএসবি থেকে কোশ্চেন কিছুটা মডিফাই করেও দিয়ে দেয়, তো ওটার জন্য একটু রেডি থাকিস। তোর মোটামুটি আন্ডারস্ট্যান্ডিং ঠিকই
হ্যাঁ
আছে, তুই করে নিতে
হ্যাঁ
পারবি, মানে
এক্স্যাক্টলি।
বেসিক থেকে অ্যাপ্রোচ করে নিতে পারবি, একটু হিন্ট
জাস্ট ওই
গুলো ভালো করে
এক্সাম্পল গুলো
শুনিস।
দেখে নিবি, হ্যাঁ
হ্যাঁ
ওটাই।
ঠিক
হ্যাঁ,
আছে,
আর হিন্ট
মেনলি
গুলো ভালো
কাউন্টার
করে শুনিস, ওরা
এক্সাম্পল
হিন্ট দেবে তোকে।
একটু।
হ্যাঁ,
আচ্ছা আচ্ছা,
হ্যাঁ
কাউন্টার
কারণ,
এক্সাম্পল গুলো একটু ভালো করে দেখবো।
হুম
হ্যাঁ
হুম,
কারণ
হ্যাঁ,
ভাই
হ্যাঁ,
দেখ,
হ্যাঁ,
তোদের
এক্সাম্পল
100 তুই 104 এরকম নাম্বার, তোদের ইন্টারভিউ হবেই হয়তো দেখবি 2 থেকে 3টে কোয়েশ্চেন, তার বেশি কোনো কোয়েশ্চেনই হবে না তোদের।
হ্যাঁ হ্যাঁ হ্যাঁ,
হার্ডলি
একদমই।
হুম।
28-30 মিনিট, তাও হয়তো না, তো এইগুলো
মানে
ছোট ছোট গুলোই দেখে।
আমাদের তো এরকম এবারে 20 মিনিট করে অ্যাসাইন করেছে, মানে একটা 1 ঘন্টা এরকম
না না, ওটা জাস্ট
তিনজনকে
ওরকম
ডেকেছে
লেখা
তো।
আছে, ওটা আমাদেরও লেখা ছিল,
প্রত্যেক,
ওটা ভাবিস না।
ইন্টারভিউ এর টাইম কখনো
ও
ঠিক থাকে
ওটা
না,
এরকম
মানে
লেট হতে
হ্যাঁ
থাকে?
হ্যাঁ হ্যাঁ
হ্যাঁ,
হ্যাঁ হ্যাঁ।
মানে আগের বার এমনও হয়েছে যার
আচ্ছা আচ্ছা
ইন্টারভিউ ওই দুপুর 1টা করেছিল, সে 4টে 5টা ইন্টারভিউ দিয়েছে। তো ইন্টারভিউ লেট হতেই পারে।
আহ,
আর
আচ্ছা
থিওরেম
আচ্ছা,
গুলো
ঠিক আছে
মোটামুটি
ঠিক আছে।
মানে এস্টিমেশন টেস্টিং এ যে থিওরেম গুলো আছে, ওগুলো একটু দেখে যাস। আর ওটা সব হার্ডকোর প্রুফ লাগবে না, বাট ইনটিউশন গুলো
হ্যাঁ
নিয়ে যাস, এটাই বলবো।
হ্যাঁ, আর হচ্ছে মানে অ্যাজাম্পশন গুলো একটু দেখে যাস, মানে যে যে অ্যাজাম্পশন গুলো আছে না, মানে রেগুলারিটি কন্ডিশন গুলো, এগুলো একটু দেখে যাস, মানে তোকে একদম রিগোরাসলি ঢুকতে বলছি না, জাস্ট দেখে যাস, ঠিক আছে? বুঝলি?
ঠিক আছে ঠিক আছে।
হ্যাঁ হ্যাঁ,
হুম হুম।
তাহলেই হবে,
অল দ্য বেস্ট।
কোনো চাপ নেই। জাস্ট চিল থাকবি আর মানে একদম কাম হয়ে ইন্টারভিউ দিবি। মানে ওরা ভাববার টাইম
হুম,
দেবে, ঠিক আছে?
ঠিক
মানে ধর
একদম
ভাবতে পারছিস না, একটু টাইম নিয়ে ভাববি, ঠিক আছে? ওরা টাইম দেয়, কোনো সমস্যা নেই।
ঠিক আছে। আচ্ছা
ওকে।
আচ্ছা আচ্ছা, ঠিক আছে।
হুম হুম, ঠিক আছে, অল দ্য বেস্ট।
বেস্ট অফ লাক।
হুম, লিভ
ঠিক
করে
আছে,
যাবো?
yes
হ্যাঁ
yes
করে দে।
ওকে ওকে, থ্যাংক ইউ থ্যাংক ইউ।